Okay, Richard, I've worked through this problem that we got stuck on, and I believe that this entire expression that's given in that problem we were working on is going to come out equal to 1, and we'll see if it does so when I work it out again here with you. So the original expression was 2 tan of pi over 8 is 1 minus tan squared of pi over 8. So theta, as we said, must be pi over 4. And the reason is because if you take pi over 4 and you cut it in half, which is like multiplying by 1/2, you get pi over 8. So theta is pi over 4. So let's take this step by step. Step 1, 2 tan of pi over 8 is going to be equal to 2 times, and then we're going to use this half angle identity with theta equal to pi over 4 and plug all that in. And I'm going to show every single step to make sure we've got this. So it'll be 2 times the sine of pi over 4 over 1 plus the cosine of pi over 4. That's our numerator. Now our denominator. That'll be 1 minus, and notice again we've got pi over 8, which is half of theta, which is pi over 4. So it's going to be 1 minus sine of pi over 4 over 1 plus pi over 4, but this time it's squared because it's tangent squared of pi over 8. So that's what I would do in step 1. In step 2 now, I'm going to go ahead and plug in my exact values that I know from my unit circle. So once again, starting with the numerator, that 2 out in front can just be put on top with the sine of pi over 4 because it's 2 over 1 times that fraction. So I'll have 2 times the sine of pi over 4, which is square root 2 over 2. Clearly we see those 2's are going to cancel. Over 1 plus the cosine of pi over 4, which is also square root 2 over 2. Oops. That's our numerator. Our denominator, we've got 1 minus, and then this is sine of pi over 4, which we've decided is square root 2 over 2, divided by, oops, I dropped the cosine here, didn't I? 1 plus the cosine of pi over 4, which is also square root 2 over 2. But this time it's got to be squared. Okay? So then what I continued to do was to simplify my numerator. So 2 square root 2 over 2 is just square root 2. And then if I get a common denominator on the bottom of my numerator, that common denominator will be 2. So I multiply the top and bottom here by 2. And I'll get 2 plus root 2 all over 2. There's my numerator, but I can take that a step further because I know that this is the same as I'm dividing by a fraction. It is the same as multiplying by the reciprocal. So this is root 2 times 2 over 2 plus root 2. So that, of course, is just 2 root 2 all over 2 plus root 2. So now for my denominator. I've got to take 1 minus that fraction squared. Well, squaring that top part of the fraction is pretty easy. Square root 2 over 2 times square root 2 over 2 is 2 over 4, which is 1/2. Okay? But on bottom, to square that, I've got to take the 1 plus square root 2 over 2 and FOIL it with another 1 plus square root 2 over 2. So if I do first times first, I'll have 1. If I do outside times outside, I'll have 1 root 2 over 2. If I do inside times inside, I'll have another 1 root 2 over 2. And if I do last times last, I'll have root 2 times root 2, which is 2, over base denominator times denominator, 2 times 2 is 4, which of course is 1/2. Now, again, if I continue on with simplifying my denominator, I have 1 minus a half on top, which is a half. And on bottom, these can be combined. They are like terms. They would be 2 root 2 over 2, which is root 2, plus 1, plus a half. If I combine these things that do not have a radical, my common denominator would be 2. So 1 is the same as 2 over 2, and 2 over 2 plus 1 over 2 is 3 over 2. So I have 3 over 2 plus root 2. Now, this is where I think I goofed in our time together this evening. I can think of this 1/2 as being 1 over, and then I can put this 2 down in the denominator with what's already there. If I do that, it makes the process a lot simpler. I'll have 1 on top, and now when I distribute that 2, I'll have 3/2 times 2, which makes those 2's cancel, so I'll have 3. And then when I distribute the 2 to the root 2, I'll have plus 2 root 2. So now I've simplified my denominator to just be 1 over 3 plus 2 root 2. But remember, I still have a 1 minus in front of that. So I have a 1 minus 1 over 3 plus 2 root 2. Once again, I need common denominators. So I'm going to need to multiply this first value, 1, by 3 plus 2 root 2 on top and on bottom. So I'll have 3 plus 2 root 2 over 3 plus 2 root 2. Subtract 1 over 3 plus 2 root 2. Now my denominators are the same, so I can just put them over in one fraction, and I'll have 3 plus 2 root 2 minus 1, which is 2 plus 2 root 2, all over my common denominator of 3 plus 2 root 2. Are we having fun yet, Richard? That's what you're asking. So now we know all of this simplifies to this. So I've left my denominator in green here to hopefully help with this process. So now I have in the numerator a fraction, not a very pretty one, but a fraction, divided by another fraction. And so we know that that is multiplication by the reciprocal. So I can take the numerator, which is 2 root 2 over 2 plus root 2, and I can multiply it by the reciprocal of my denominator, 3 plus 2 root 2 all over 2 plus 2 root 2. And now, whenever there's a plus or a minus, that's like a binomial, so I have to enclose it in parentheses. On top, I have to distribute the 2 root 2 to everything in the binomial that follows it. And on bottom, I have to FOIL.